Hello everyone, welcome to In 5 Minutes. In this video we are going to see integration over a given volume. So till now we have seen how we can use the double integration to find an area. But now we will see how we can use the integration to find the volume of any three-dimensional figure. Why? Because volume is for three-dimensional figure and area is for two-dimensional figure. So we know that volume is nothing but area into height, because in two-dimensional figure, let's say we have a circle. In two-dimensional figure we have a circle, then the area of circle we all know we can find out by using double integration as pi r square, where r is the radius of the circle. When this circle is represented in 3D format, it forms a sphere. Okay, so it forms a sphere. When we have sphere, we have the circle also and we have the height of that sphere also. That means we will find the area as we used to find in two-dimensional figure, and we multiply that area by height. That means we will cover the entire sphere. Okay, this will be more clear when we take a cylinder. Let's take a cylinder. So cylinder is something like this. Okay, this is z-axis, this is x-axis, and this is y-axis. So we have to find the volume of this cylinder, and we cannot apply the direct formula of the volume here because we have to use integration to find the volume. So to find the volume of this sphere, what we are going to do? We know that volume is area into height. What is the height of this cylinder? We will find the height of this cylinder. We will integrate that height. Okay, so height is on the z-axis. So we will have the limits of z equal to something to z equal to something. So we will have the limits of z equal to something, z equal to something, and here we will have the function of volume into dx, dy, dz. Why dx, dy, dz? Because we have the three variables or three axes. Now we have covered this height. Now we have to find the area. So we have to cover this entire volume. Okay, so let's say this is our strip parallel to z-axis, and we will move this strip from this point till this point. This can be represented in two-dimensional form as, when we look from above in xy plane, we will see this cylinder as circle. Okay, so we got the limits for height. Okay, then we will, from here we will find the limits for area. So we will have the limits for area, that is x equal to y equal to, then this will be the triple integration. So basically what we have to do, we have to find the limits for height, which will be from the z-axis or from z equal to something. Then we will see our that three-dimensional figure in 2D format, that is in xy plane. When we see that 3D figure in xy plane, we will get circle, okay, for cylinder, and we know how to calculate the area of this circle by considering a ray or by considering a strip parallel to x-axis or y-axis. In that way we will find the limits for x and y, and then we will integrate these three, all the things together. We will get the volume of the cylinder or volume of any three-dimensional figure. Okay, so this is the basic of integration over a given volume. Now we will see some standard figures. Let's say this is our coordinates axis. We have a plane x plus y plus z equal to 1. That means that this is a plane. Okay, so this is a plane, 3D plane. Okay, so this plane will cut x, y and z axis at some point. So to find a point on z axis, we will put x and y equal to 0. When we put x and y equal to 0, we get z equal to 1. So this is one point of intersection of this plane. Similarly, to find a point on x-axis, we will put y and z equal to 0. Then we get x equal to 1. So this is x equal to 1. Then we again do similar thing. We will get y equal to 1. When we join these 3 points, we will get the plane. Okay, so this is our plane. Okay, so we have to find the volume enclosed by this plane. Okay, to find the volume enclosed by this plane, we know that formula is triple integration. Here we write the integration limits for z, then x or y or x. Okay, as we know, volume is area into height, and we assume height to be on the z-axis. So the height will be from this point till this point. Okay, so what is the lower end of this point is on the xy plane. In xy plane z equal to 0. and upper end is on this plane, and this plane is x plus y plus z equal to 1. From here we will get z equal to 1 minus x minus y. Always remember, in 3D diagram, height will be always from z, that is z equal to something and z equal to something. Now we have found out the height. Let's say this is our column, or we used to assume strip when we used to find area. So this is our strip. Now we will move this strip from this point here in this fashion. Okay, when we see this part in the xy plane, we will have something like this triangle. So we will move this strip in this way. Okay, so this strip is parallel to z axis, and we are moving this strip from this point in this way. Okay, so from here we will get the limits of x and y. Okay, and then we will write these limits here. Then we can calculate volume enclosed by this figure. Similarly, we can have cylinder. So let's say this is our cylinder. So again we will assume one column or one strip parallel to z axis. This is z axis, this is x axis, and this is y axis. Then we will write the lower limit of this column and upper limit. After finding the lower limit and upper limit of z, we will consider this cylinder in xy plane. So in xy plane, when we look from here, we all know, we have done the engineering drawing subject. When we look from up, the cylinder will look as circle. Then we find the limits for x and y. Then we will integrate all these things and we can find the volume. This will be more clear when we see the problem on this type. So the problem on this type we will see in our next video. So stay tuned for our future lectures.